Hello, folks. I want to talk through something that came up this week while working with a coworker on Python's various ways of defining a new function which wraps another one. And of these many reasons you may want to wrap a function, one of the particularly common cases is where you want to take an existing function that has multiple inputs and pin some of those input values to be the same every time you call it, yet leave others available as new inputs to the function. So this is called partially applying a function, and there are three main ways of doing that in Python, which we'll go through. There's creating a function using the def syntax as if it were any other function. This one just happens to perform a particular type of operation, just pinning. There's lambda, which provides a very quick syntax for defining these pinned functions. And finally, the partial method from the functools module, which has which is again specifically designed for creating these sorts of pinned, partially applied functions, and gets around a few of the issues that I'll talk about that plague def and lambda. So before we get too far in explaining how to do these type of operations, let's first give a motivating example. So here I've got two functions. One evaluates a polynomial. I pass it the value and the coefficients. And the other computes the derivative of an arbitrary function. And you'll note one of its inputs is a function, something that takes only a function that has only one input and produces only one output. So thus far, these two Lego bricks don't fit together. Evaluate has two inputs. Call the differentiate takes one input. So the easiest way, or probably the most obvious one, is to create a new function that calls evaluate and fixes one of the parameters. So here I've got coefficients. I set it to 1, 2, and 3. And I use that inside of the function body such that when I evaluate the wrapper, I only need one input. And I can pass this wrapper to my differentiate function and it works perfectly. This is exactly what I needed. Now, this is kind of complicated for being able to produce a function that only pins the inputs. And Python provides a quick route for creating such functions known as anonymous functions in other programming languages. Python's, they're called lambda. You can check out the reason for that if you go to this Wikipedia page, which also explains many of the places where such anonymous functions are used inside of other languages. So a fun Wikipedia dive if that's the kind of thing that interests you. But if it doesn't, the quick way to use this is just start with the word lambda, define the number of new inputs on your functions and the letters that they correspond to. So here I've created one input, x. Then write out your function body. Oh, sorry about that. Um, then define your function body. So here, this acts just like the previous wrapper I have earlier. I can call it with the differentiate, everything's happy. Now, the reason why there exist other methods for being able to do these kind of operations is because def and lambda have a known problem. They're dangerous to use because they have a side effect. If I change the values of coefficients, that changes the behavior of the wrapper, which it may be something that you want in your code base, but it's something that I personally try to avoid. Side effects make it harder to, or make me have to remember more things about how wrapper works than is immediately specified on the label. Oh yeah, there's one input, but that's not all the information I need to know how it operates. And for that reason, some style guides like Flake 8 actually prohibit you from assigning lambda values to a named variable to try to and presumably to try to limit your code from having as many side effects. There are also problems with using lambda functions for parallel processing. So if I try to use a lambda function in the process pool executor, oops, got a bug here. wrap was from a previous version of this code, so let me actually run it from the top. Yeah, there we go. When I run this function, it fails because lambda functions can't be pickled. They're really not designed to be reused and saved. So the Python language, I guess, doesn't provide support for sending these functions between multiple Python processes. Now, I will note there are ways around that. Cloud Pickle and Dill do let you pickle lambda functions, but I personally don't try to use that feature because I'm sticking closer to the language's well-established conventions. Makes it easier for me to reason about whether the code will work or not. Fewer tricks makes life easier. Now, partial is, as I mentioned, the tool for being able to fix such issues. If we look at this code here, what I do to create a partial function is I call the partial method from functools and then provide a list of the arguments I want. So here I'm giving a keyword argument of coef. I'm sending it to the list coefs. And that function wrapper, now I should have gone through and reran this notebook, works just as before. And I can change the value of that coefficient, and it's going to still behave as it did normally. So I can change this to whatever I want, and it's not going to affect the execution of the wrapper. No side effects. Now, that's because the value of that list is not read when the function is being executed, as was the case for the def and lambda, but instead it's stored along with the wrapped function. You can see here. Now, I simplified something here. List. The reason why I set coefs to a new list rather than altering the same one is because a variable coef doesn't actually correspond to a list. It's a reference to a list. And while I won't go into the details on kind of differences between values and references in Python in this video, I'll just quickly show you what that means through kind of actual live code editing. So here you can see wrapper is working using this current values of the list. But let's, instead of changing it, we edit it. We have a side effect now. That's because I edited the list, which is being referenced by the variable coef. Different thing than editing the values of the variable coef. We can talk, I should make a video explaining references and why some other things in Python act the way they do as a result, but I wanted to keep things short for today. So here we can see that the partial function actually executes the way one would expect it to on a multiple processor system. I can pass wrapper over to another process because I'm passing the values of coef along with it as one of this keywords attributes. It can work on that remote system without having to access the value of the variable coef held on the original system or on the original process. That's also a simplification. The code here only works because Linux. The way that multiple processes in Python works on Linux is different than Windows and Mac. And as a result, I can send the function evaluate, which is being wrapped, to that remote process on Linux, which means this function will work remotely, whether it was Windows or Mac, or whether it was Linux, but that other process was on a different computer, like I'm running inside of a compute cluster instead of on my desktop. This wouldn't work. But boy, is that a complicated problem that we're not going to go into. So now that I've muddied the waters, let's make this all simple again. There are 3 ways of pinning function values. Lambda is the one you'll probably use most often. It's for writing short functions where I create a new interface that fixes the values of the wrapped function to either specific values or functions of those new inputs. This is great for simple things, but has side effects and doesn't work great with parallel computing. Def lets you do even more complicated things than lambda. Instead of having just a one-line statement, you could have arbitrary code being executed along with your wrapped function. Say if you want to transform those input variables to something more complicated than just um, a simple one-line expression, you could do that with def. And then finally, partial is a way that gives you a very simple thing that you can do: assign the arguments to specific values. But because it's simple, it's allowed to do more complicated things like operate without less of a risk of side effects and be able to send to remote processes more easily than you could do with def or lambda. So in short, those are the three different ways you can use partial functions in Python and their pros and cons. I hope you're having a good day.